Hi again. This video is me going over the acceleration problems that you had to do in class on Monday with the substitute. For those of you who completed the problems, you got credit on Skyward. For those of you who did not hand them in, who did not complete them, or did not hand them in, you did not get credit. However, whether or not you handed them in, what I'd like you to do right now is go over these problems as I'm going over them. So again, whether or not you completed these problems last class, I'd like you to go over them as I go over the answers. There are photocopies available from the substitute if you do not have it with you, again, so you can get a copy and again go over it as I go over it. I'm going to start with number 1. If you remember, acceleration is final velocity minus the initial velocity divided by the time. So it's basically the change in speed divided by the amount of time. So if we go to number 1, I'll do 24 minus 0, final velocity minus initial velocity divided by time. So it's 24 divided by 3, and it's 8 meters per second squared. Number 2, 35 minus 0 divided by 5. Our time is here. Okay, final velocity minus initial velocity divided by the time. So that'll give us 7 meters per second squared. Number 3. Here we have something a little bit different. Our initial velocity is not 0, it's 20. So the vehicle, or whatever this is, started at 20, finished at 60. So 60 minus 20 divided by the amount of time. So it's 40 divided by 10 is equal to 4 meters per second squared. All right, number 4. We have 150, final velocity minus initial velocity, 50, divided by 5. So we have 100 divided by 5. I don't have any space here, so 20 meters per second squared. Number 5, we have 1200 minus 25 divided by 3,600. So we have 1175. Oops, it equals to 1175 divided by 3,600. Now, for the life of me, don't ask me why I use these numbers. Divided by is 0.33, I'm rounding it, meters per second squared. So let's move on to the problems. Now the problems you're going to get here are what you're basically going to see in a quiz or a test or an exam. So for number 6 here, a car accelerates from standstill. So we're going to assume that this means 0 meters per second to 60 meters per second in 10 seconds. What is the acceleration? So acceleration is final velocity minus initial velocity divided by time. So 60 minus 0 divided by 10. 60 divided by 10 is 6 meters per second squared. So that's our answer for number 6. So let's start with number 7. A car accelerates from 25 to 155 in 2 hours. So here we have our initial velocity. Here we have our final velocity. Oops, sorry. And here we have our time. What is the acceleration? So final velocity 155 minus 25 divided by the 2 hours. So we have 130 divided by 2 is 65, and now we have kilometers per hour squared. Simple. So basically, what does this mean? It means that every hour, for 2 hours, the speed increased by 65 kilometers per hour. Every hour. Let's go to number 8. Now I know I'm going through these pretty quickly. I do promise that I will be in school on Friday and I will go over these on Friday as well, because you will have a quiz coming up next Friday. So a week from this Friday. So April 5th or whatever that is. So I will go over these again. However, these videos will be available in case you want to look at them yourself at home as many times as you want. Number 8, a train is accelerating at a rate of 2 meters per second. Now this is a little bit different because now they're giving us the acceleration. So they're actually giving us the acceleration. The acceleration is 2. If the initial velocity is 20, this is our initial velocity, is 20. What is its velocity after 30 seconds? Now we have time. This is our time. We have the initial velocity. We have the acceleration. We don't have the final velocity. So let's fill in our equation with the information that we have. So we have our acceleration. It's 2. Final velocity we don't have, so I'm going to put it as x minus the initial velocity, which is 20, divided by the time, which is 30. Now this is where your algebra is going to come in handy. So in order to isolate the x here, I'm going to bring in my 30. My 30, I'm going to bring it over to the other side of the equal sign. So I'm going to do 60 is equal to x minus 20. So the 30 that's here, I'm bringing it over to this side of the equal sign. So 30 times 2 is 60. So I'm left with x minus 20. So again, I want to isolate the x. So I'm going to have x is equal to 80. So what I did is I brought over the 20 over to this side. And you remember you always do the opposite operation. So x is equal to 80. So what does this mean? It means that my final velocity is 80 meters per second. I probably shouldn't put that there. So 80 meters per second. Now, I want to take a minute to actually maybe help you understand what this is telling us exactly, what this problem just solved for us. Okay, this problem told us, so I'm going to use this space here. This problem told us that a car started at 20 meters per second. So it was 20 meters per second when it started. The problem continues to tell us that it started at 20 meters per second, yes, and that every second, so I'm here, every second, for 30 seconds, its speed increased by 2 meters per second, which is its acceleration. So again, its initial velocity is 20, and what this problem is telling us is that every second, its speed went up by 2. So after the first second, it was 22 meters per second. After, it was 24. After that, it was 26. And if we keep going, now I don't have space nor the time to keep doing this, but you could do this on a scrap piece of paper next to you right now. You can actually do it. So if you continued this for 30 seconds, if you did this 30 times, you would actually end up getting 80 meters per second, which is our final velocity. Okay, so again, initial velocity is 20, and what this problem is telling us is that every second, its speed goes up by 2, because that's its acceleration. Now for the last one, number 9, I'm going to do this in black here. I'm going to squeeze everything in this little space. I'm sorry about this. This is a straightforward problem. A runner achieves a velocity of 11.1 meters per second 9 seconds after he begins. What is his acceleration? They don't talk about initial velocity. In this kind of problem, we will assume that the initial velocity is 0. So at this point, acceleration is equal to the final velocity minus the initial velocity divided by the time. Now again, I'm sorry for not having just round numbers for you to be able to do this without a calculator. But if you did this, you'd probably get an answer of 1.3 meters per second squared. I believe that was the last of our problems. I will have these videos available under the physics tab in Moodle, both this one and the one that you saw on Monday where I go over acceleration. They'll both be available to you. On Friday, make sure you bring all your materials, including your textbook and your notes, as well as the graph problems that you will continue or finish up today.